Welcome back. In the last session we started problem number 6, student workbook problem level 1, and we were in between, and I told you how to solve it also, and I told that the power dissipation across the GNR diode is nothing but Vz into Iz, and Vz is already known to you, which is 9.5. If you know Iz, problem is over. And PT, the power dissipation across the transistor, is nothing but VCE into IC, and VCE is nothing but your output voltage, that is also known to you. And if you know IC, problem is over. If you know IC, Iz, problem is over. But the problem is not simply power dissipation, asking for maximum power dissipation. Means maximum Iz, maximum IC. That maximum Iz, maximum IC is possible only when VI is maximum. Only that is what is the variable you have, right? Other than that, we don't have any variable to see the maximum currents, right? Therefore, now we need to take VI max, which is 30. When you take VI 30, maximum source current, maximum GNR current, maximum collector current, you'll get everything. Okay? Now, let's solve. Maybe you can find Iz. To find Iz. To find Iz. How will you find? Okay, I can tell you one thing. He told that the current which is what is flowing through RB can be neglected. Then tell me what is your IB? The same Iz. Therefore now we can get the relationship. Okay, that's fine. Therefore what is your Iz? Your IB is nothing but your IC. Therefore what is your IC? We know that the collector current IC is equal to approximately beta into IB. This is what is your collector current. Okay. Therefore now tell me what is your IB? IB is nothing but Iz. Therefore beta into Iz. This is what is your collector current, right? You can call this as equation 3. And we know that. Tell me if you know Iz, indirectly we know IC. That is what we need, right? If you know Iz, similarly we can find IC also from this equation. If you know Iz, problem is over. Now tell me what is your source current. Let me call this as source current. That is your fundamental equation. Is is equal to the source current is equal to your GNR current plus your collector current. What is your collector current? That is beta into Iz. If you do that, you will get 1 plus beta into Iz. This is what is your Is. Therefore, tell me what is your Iz. Therefore, your Iz is nothing but Is divided by 1 plus beta. Therefore, tell me how can you find Iz maximum? Iz maximum is nothing but Is maximum. When Is is maximum, then only Iz is maximum. 1 plus beta. What is beta? Beta is given 99. Therefore, it is 100. If you know Is maximum, then problem is over, right? Therefore, now this is what is equation 4. To find Is maximum, the maximum source current. First of all, what is Is? Is is nothing but your input voltage Vi minus your output voltage V0 divided by your Rs. What is the Rs? Rs is given 20 ohm. Therefore, I want Is maximum. When I say Is maximum, that is nothing but your Vi is maximum minus V0 divided by Rs. Therefore, tell me what is your Is maximum? Your Is maximum is equal to Vi maximum. What is Vi maximum? Vi maximum is 30 minus V0 10 divided by Rs, that is 20. Therefore, can I say this is nothing but what, 1 ampere? Yes, you got Is maximum, that is 1 ampere. Then what is equation 4 implies? What is your Iz maximum? For Iz maximum is equal to Is maximum 1 divided by 100. What is 1 divided by 100? 0.01, which is 10 milliampere. You got Iz maximum. This is what is your Iz maximum. Therefore, what is your PZ maximum? 1 implies PZ maximum is equal to VZ 9.5 into 10 milli, which is nothing but 95 milliwatt. This is what is our PZ maximum. Similarly, 2 implies what is PT maximum? Power dissipation across the transistor is equal to 10 into IC maximum. What is IC? We already know from the equation 3. Therefore, 10 into what is beta? 99 into IZ maximum. IZ maximum is already known to you, 10 milli. Therefore, this is nothing but 100 into 99 milli, which is 9900, right? Which is 9.9 watt. PT max or 9900 milliwatt. Therefore, what is the answer? 95 milliwatt and 9.9 watt. Therefore, answer is C. Your answer is C. I hope everybody understood the procedure. Simply network analysis. Okay? Take it. Done, right? Now, problem number 7. The 6-volt Zener diode showed in figure has 0 Zener resistance and a knee current of 5 milliampere. Actually, RZ is 0, which is nothing but ideal Zener diode breakdown, and IZ minimum is equal to 5 milliampere. Asking the minimum value of R. R is nothing but your load here. RL minimum. So that the voltage across it does not fall below 6 volt. That is nothing but we want regulation operation. Okay. I think we solved a similar problem. It is similarly same procedure. But in the problem statement, this is what is R. But let me call this as RL. This is what is my load. And this is 50 ohm source resistance and 10 volts. Okay, and this is what is having 6 volts Zener. This is straightforward. We can solve it, right? Now, if you observe clearly, this is what your output voltage. That's fine. Now, what do you want to find? We want to find RL, right? First of all, let me call according to that KCL. What is your KCL? This is your IS. This is your IZ. This is your IL, and this is what your output voltage, that is what is 6 volts, right? Therefore, tell me what is your RL? Your RL is equal to your V0 divided by IL. What is V0? 6 divided by IL. This is what your RL. Therefore, what is RL minimum? RL minimum. This is minimum when this is maximum. Therefore, 6 divided by IL is maximum. What is IL? Therefore, RL minimum is equal to 6 divided by, first of all, what is your IL? IL is nothing but IS minus IZ. IS minus IZ. Maximum. When is this maximum? Your input is constant, it's not variable. Then it is nothing but IS minus, when IZ is minimum, then only this is maximum. IZ minimum. Right? Therefore, what is IS? Therefore, IS is nothing but what? Input voltage minus output voltage divided by RS. What is input voltage? 10. Output voltage? 6. 50. Which is nothing but 4 divided by 50, which is nothing but 80 milliampere. Right? Then what is your IZ minimum? That is already given. Therefore, this is what is your RL minimum. Take this as equation 1. Therefore, 1 implies your RL minimum is equal to 6 divided by 80 milli minus IZ minimum 5 milli, which is 6 by 75 milli will become kilo ohm. 6000, which is 6000 divided by 75. If you do, this is nothing but what? 80 ohm. RL minimum is equal to 80 ohm. This is the answer. Therefore, what is the answer? Answer is B. Answer is B. Take it. The diode in the circuit shown has V on is 0.7 volt, which is nothing but V gamma, but is ideal otherwise. Second approximation, if Vi is equal to 5 sin omega t, minimum and maximum values of V0, minimum and maximum values of V0 respectively. Circuit is this is 1 kilo ohm, this is 1 kilo ohm, this is what is your diode. Okay. Now again, if you know the status of diode, that is nothing but what? If you know status of diode, that is network analysis. How to find status of diode? Actually, we can do it simply, but maybe if you have any confusion, it is simple. Actually, I know this is 2. If VA is greater than, we need 0.7. If VA is greater than 2.7, then it will conduct. Otherwise, it will not conduct. Okay? Maybe for your understanding, open the diode. Visualize. We can visualize. Open the diode to find diode status. To find diode status. Then what you get? It is not to find output. It is to find. Therefore, this is what is your 2 volt battery, and this is your VI. This is 1K, 1K. Now you bring back your diode. If you see here, tell me it is open. When it is completely open, there is no current. If there is no current, the VI will come here. If you observe clearly, this you will have VI and this you have 2 volt. Tell me for what voltage it will be conducting. Case 1. Only when VI, because it is 2, it should be more than or equal to 2.7. Then only it will have 0.7, greater than or equal to 0.7. Therefore, only when VI is greater than or equal to 2.7, then only your diode will be on. If diode is on, then what is your circuit? Your circuit is V gamma and 2 volt. This is what is your 2 volt and 0.7, and this is 1K, this is 1K, this is VI, and this is V0. Then how will you find V0? Nodal analysis. If you know nodal analysis, V0 minus VI divided by 1K plus V0 minus 2.7 divided by 1K is equal to 0. 1K will be cancelled. 2V0 is equal to VI plus 2.7. Therefore, V0 is equal to VI by 2, right? Or VI plus 2.7 by 2. This is what is this. This is what your V0. Now, case 2. When VI is less than 2.7. When if VI is less than 2.7, diode is off. Diode is off. When diode is off, then what is your circuit? I think same circuit. This is your resistor. It is completely open. Then if it is open, actually not required. This is what is your output. This is your V0, this is your Vi, and this is what is 1K. Even if it is open, nothing. Therefore, what is your V0? V0 is equal to Vi. Right? If you draw the transfer curve, the transfer curve is nothing but this is Vi and this is your V0. What is the break point? The break point is 2.7. The break point is 2.7. Less than 2.7, V0 is equal to Vi. More than 2.7, this is what is nothing but Vi plus 2.7 by 2. Y is equal to mx plus 2. The slope is decreasing basically. Therefore, up to this, I think up to this, it is like V0 is equal to Vi. Then later on, it will be like this, the different slope. Therefore, here V0 is equal to Vi, but here V0 is equal to Vi plus 2.7 by 2. A different slope. Y is equal to mx plus c. Okay. Now, what is your input? Your input is a sine wave. Let's see what you get. Therefore, when you have a sine wave, this is what your sine wave. Okay. The maximum value is 5, and now this is what is our minus 5. Now let's see. The break point is 2.7. This is what your break point, 2.7. Actually, we want V0, right? Then if it is less than 2.7, same as your input. Less than 2.7, same as your input. Right? And if it is more than 2.7, then it is nothing but increasing but not. Tell me when VA is equal to 5 volt. When VA is equal to 5 volt, then what is your V0? When VA is 5 volt, when your input voltage, that is what is maximum, 5 volt, then what is your V0? V0 is equal to 5 plus 7.7 by 2. What is 7.7? 3.5. 3.8 is 3.85, right? 3.85 volt. Then what you get? From here, the slope is different. Then you will get like this. And what is this value? This value will be 3.85, and this is minus 5. Therefore, tell me what is the maximum value? The maximum value is 3.85. Minimum value is minus 5. What is the answer? Minimum and maximum. Answer is C. Answer is C. With this I can say level 1 is over. I hope everyone understood. Same procedure. Once you know the status of diode, done. It is simply network analysis and just tracking and having the transfer curve from there, translating into the actual input to output. That's it. From the next session onwards, this is what is level 2. Okay. See you. Thank you. I'll meet you in the next session.